Hello everyone, welcome to today's GFG POTD problem. So let's see what the problem says. So given an array of n positive integers which can contain integers from 1 to p, where elements can be repeated or can be absent from the array. Your task is to count the frequency of all numbers from 1 to n. Make in-place changes in array such that arr of I equal to frequency of I. Assume one base indexing. The elements greater than n in the array can be ignored for counting and do modify the array in place. Okay. So let's quickly take an example and understand what the problem is trying to tell us. 2, 3, 2, 3, 5. So what the problem is saying is that there is an array which will contain elements from 1 to p in the range 1 to p. And let's say now the p, right, the value of p is 5, right? So the array will contain the elements 1 to 5, and some elements between 1 to 5 can be absent, and some element can have multiple frequencies from 1 to 5, from the range 1 to 5. So here you can see there are elements from 1 to 5, but there are few elements missing, like 1 is missing, 4 is missing, and few elements like 2 and 3 have frequency of more than 1. Okay. So what the problem is trying to tell us is the output should be uh, the frequencies should be in the same array. The frequency of the elements should be in the same array. Now, so for example, is there a 1 here? No, there's no 1. So it will come 0. Is there a 2? Yes, there's a 2. So, and what is the frequency of 2? 2. 2 times it has come 2. Okay. Is there a 3? 3. Yes, there is 3. 2 times the frequency is 2. Is there a 4? No. Is there a 5? Yes. So you can see the output here, right? The expected output is 0, 2, 2, 0, 1. 0, 2, 2, 0, 1. So this is the output we are getting. Okay. And you have to keep in mind that it is one base indexing. Okay, one base indexing. Here it is one base indexing. Okay, so there can be two approaches, right? Okay, and first of all, what is the time? The expected time complexity is O of n, and space complexity is O of 1. Okay, O of 1. Okay, so let's see what can be the what knife first approach comes into your mind. So let's see. So what we can do is we can have a map, right? We can have a map which will store the frequency of these elements, and then we can simply iterate the array and find whether that element 1 to n is present or not. For example, what we can quickly see map of int right, m equal to new hash map, right, right. And what simply we can do for I equal to 0 to n, what we can simply do is map dot put, right, map dot put, right, arr of I. And for different languages the syntax can be a bit different, but the idea here is to add the frequencies in the map, get or default, right? So get or default, what does this function do? If this element is found, then return something, else if not found, then 0, return 0, right, plus 1, right? So we are calculating the frequency of elements here. Simply we can do here, if m m dot get, right, arr of I, right? Simply we can do this, or else yeah, m dot put arr of I, then m dot get or default, right? Get or default, it will get this value, the frequency of this element if it is present, else it will 0, else it will return 0, and then we simply have to add the frequency 1 to this and put. For example, 2 was found, so it will return 1, right? The frequency of 1, and then we are adding one more 1 here, and we are putting arr of I 2, 1, right? So this is a way. So this is the knife approach. Then simply what we can do is for, right, now we have to add the frequency in the same array, right? Arr of I equal to m dot get, right, or default again, default arr of I plus 1, because it's 0 base indexing, I plus 1 to, it will be n minus 1 here, n minus 1. Okay, n minus 1 and 0, right? Get or default plus 1, no, sorry, that's it, right? That's it. So this will give you the answer. Okay, so it will start 0, right, but our elements are starting with 1, right? So we are searching whether in the array of 0th index, whether we have element 1 present or not, right? So this is a naive approach, but the problem here is we are taking extra space, that is O of n, right? We are taking extra space, that is O of n. Now let's see an optimized approach wherein the space complexity and time complexity adheres to what the problem is asking. So let's take an example 2, 3, 2, 3, 5. So what can we do, right? What can we do so that we achieve O of 1 extra space and O of n time complexity, right? So if you see the condition, right, the elements in the array will always be in the range of 1 to p, 1 to p, right? So whenever there is whenever there is a condition like if there is an array and the elements are will be in this range, in some range, basically in some range. So, and if it is asked that what is the frequency, right? What is the frequency of the elements or something like that? Then what we can do is we can store the elements in their right place. So let's try run this example and you will understand what I'm trying to say. So yeah, so what I'm trying to say here is, for example, right? For example, let's take 2, 3, 2, 3, 5. So in this approach, what we are going to do is, when we'll iterate through the array, and whenever we encounter an element, right, we are going to place that element in the right place, in its right place. So if it is 2, right, if it is 2, then according to the one based array indexing, what will be its position? 2 will be placed here, 2 should be placed here, right, 2 should be placed here, right. If it is 3, right, so where should 3 be placed? Actually, what is the place of 3? Right place, 1, 2, 3. 3 should be placed here. So this approach, right, wherever there's some range given, we can place the elements in the right position whenever the elements are given in some range. Okay. So what we are going to do, we are simply going to iterate the array. We are going to place the element in its right place, right? This is the approach. In this way, we are going to go. Now let's see. We can quickly, what we can do is we will write the code so that you will understand. So what is P in this example, right? P is 5, right? Okay. So what we need to do is, see, first what we'll do, we need to place all the elements in the right place, right? For I equal to 0 to n, right? So how are we going to do this? How are we going to do this? What we are going to do simply is air of, we want to place, right, this 2. Now we are coming with this air of 2. Now air of I. What is air of I? It is 2 now, right? It is 2. Mod P. Mod P. Right? Mod P. So what it is going to give this? Air of I mod 5. Air of I mod 5. 2 mod 5. What is 2 mod 5 going to give us? It is going to give us remainder as 2. Remainder as 2 only, right? It is going to give us the remainder as 2, right? So and we want to place this element in its right position. So what is the right position? The right position is here, right? 0, 1. 0, 1. The right position is 1. So simply what we need to do is minus 1. This minus 1. This minus 1 will give you the one index, the index 1, the right position of element 2, right? And then simply what we need to do is we need to add P to it. We need to add P to it. Okay? We need to add P to it. So yes, this approach. So for example, here it is 3, right? So what the element will look like now? 2, 3, 2, 3, 5. So the element will now after this operation, it will be 8. After this operation, it will be 8. 2, 3, 5. Right? Because we're adding P to this. Okay, we'll see how to fetch this as well. Okay, we'll see this. Now one more thing before we proceed further, right? Even if P is 5, we need to increment P before doing all this operation. I'll tell you the reason why we are doing plus P. So P will now be 6. P will now be 6. Okay, so according to this, right? According to this, what it will be now? So air of 2 mod 6, 2 mod 6. Again, it will be 2 only, right? Again, it will be 2 only, and we have to do minus 1 to this, right? So 1. So here, the index will be 1. So what we need to do? The elements will be now 2, 3. 3 plus 6 equal to, we are doing plus equal to P, right? Equal to 9. 2, 3, 5, right? 2, 3, 5. Okay, I'll tell you the reason why we are incrementing P. Now we come to this element now, right? We come to this element. Okay, we are coming to this element now. Now what we are going to do? Again, according to this formula, right? According to this formula, arrow 5. Arrow 5. What is arrow 5? 9. 9 mod 6. What will 9 mod 6 give you? It will give you remainder as 3. See, you have got the element 3. Now we want its correct position, right? This is the element, right? This is the real element, right? Which was present on that index. Now we want to place this 3 on its right position. So what we'll do, we'll subtract by 1. So we'll get 2. So now, so here, this 3 will be stored now here. The frequency of 3. That we are saying that we have got 1, 3. So what will be the element now? 2, 9, right? Earlier it was 2, 3, 5, right? So now it will be 2, 9, 2 plus 6. It will be 2 plus 6 equal to 8, right? 3 and 5, right? This is the way, right? Similarly, we'll quickly go ahead now. Now we'll come here. Again, what we'll do, 8 mod 6. What will remainder? 2. We'll get the remainder 2, the real element which is there, right? And we'll do minus 1, right? To place this element into its right position. So what we get? 1. So now earlier it was 9. So we're going to add 6 to it. 9 plus 6 equal to 15. 8, 3, 5. Similarly, now we are done with this. Now we'll go here. we'll go here, right? We'll go here 3. Again 3, what we'll do? Arr of I. So 3, the arr of I is what? 3. 3 mod 6. How much? It will give 3 only. This is the real element. And then to find its right place, you have to subtract it by 1. We'll get 2, right? We'll get 2. So what we have in the 2? In the 2, we have 8 here. So we'll add 6 again. So what will the updated element now be? 2, 9, 8 plus 6, right? 14. Sorry, it was 15 now here. It was 15. 2, 15, 14, right? 3 and 5. Okay. And then we will come again over here. Yeah, here, right? Here. Now 3, right? 3 mod 6. No, we came over here, right? 3, we came over here. No problem. This is done. Now we'll come over here, right? 5. Now 5 mod 6. 5 mod 6. What will 5 mod 6 give you? It will give you 5 only. It will give you the real element 5. Now to find its real position, we'll have to subtract minus 1. So for 5 minus 1, 4. So 4, right? So 5 will be in its right place only. That is 5. Now why I incremented P earlier, right? Why did I increment P earlier? So for this case only. So if I had not incremented P earlier, what would have happened is R of I, that is 5 mod 5 here, right? Mod 5. And it would have given us 0. And then we are doing minus 1 to find its right place. So it would have given us array out of index exception only, right? So it would be minus 1. That is why we have incremented P. Now finally, what array we are getting, right? What array we are getting? 2, 15, 14, 3 and 5, right? 3 and 5. So now simply what we need to do, we need to iterate this array, right? We need to iterate this array for I equal to 0 to n. For I equal to 0 to n, and simply what we need to do is arr of I, we have to divide by p now to get the original element, to get the frequency, arr of I divided by p, that is 6, divided by p, that is 6. So see quickly, 2 divided by uh, uh, 2 divided by 6 will be, it will give you 0 only, right? 2 divided by 6, it will be 0 only. Then 15, right? 15 divided by 6, 6 2s are 12, right? So division will give you operation 2. 14 divided by 6, again it will give you 2, right? 3 divided by 6, it will give you 0. It will give you 0. And here, no, here, you sorry. So 5 plus 6, right? 5 plus 6, I forgot this. So 11, it will be 11, right? So 11 divided by 6, it will give you 1. So this is our output. I hope you have got this solution. Okay, I hope you have got this solution. So let's quickly solve this problem. Let's quickly solve this problem. Okay. So yeah. So what earlier we'll have to do is plus plus p, right? Plus plus p, right? Now we'll quickly let's solve the problem. I equal to 0. Control Z n plus plus I, right? What was our formula? R of I, right? R of I mod p, then minus 1, right? Minus 1 plus equal to p. This will give us, okay, we are storing the elements, frequency of the elements. Then again, simply you have to and iterate and simply what we need to do, r of I equal to r of I divided by p this time to get the frequency of the elements, right? To get the frequency of the elements. So let's run this. Let's see. Yes, let's submit and see that we are getting. Oh, yeah, it failed. What it is saying, array index out of bound, index 7. So yes, so let's take an example. There is a exception, a corner case which we have to handle. So here, yeah, here the example is over here. Let's see. Right, for this, right? So P is 9 over here. So the elements and array size is 2, right? So the elements will be in this array will be in the range of 1 to 9. And what should be what should be, yeah, so if you see 1 and 2 both are 0, there is no 1 and 2, so we are getting output as 0 and 0. So we have to handle corner case over here. Int index equal to, right, int index equal to -1, and yeah, and one more, just check what we want to do. If idx should be, because this, right, so 8 8 mod 10, right? 8 mod 10 will be here, for example, if we take an example 8 and mod 10, we are implementing p here. 8 mod 10 will give you 8. 8 minus 1 will give you 7. So, and array size is 2 only, right? So we have to, it has one array out of bound index, so it should be index, right? Index less than n, right? Anyways, the problem has told us that we have to ignore the elements greater than n, right? Greater than n, we have to ignore the elements, right? Right. So yeah. So let's see, it is getting solved. Yes, the solution is accepted. Thank you for watching. I hope you have understood this approach. Please like the video and subscribe to my channel. It will motivate me for you to create such videos. Thank you so much.